Exercises. Now that you have a general idea of how C-transform works and how to use the patch, here are some examples. Number 1. Make a bar rotate. We will animate a cylinder and rotate it about the x-axis, and then rotate it in some random plane. A long time ago, I wrote an M file that converts a surface's XYZ data to the patch's vertices faces format. I did this so that I could use Matlab's built-in function cylinder to create a cylinder. It spits out the XYZ coordinates, and then convert that data into the faces vertices format of patches. However way you want to create a cylinder is up to you. I just did it this way. We then create a patch with these vertices and faces. Now in the local coordinate system of the bar never moves in that system, and we must save the vertices somewhere. I usually save them in the user data of the object so that I don't have to keep track of which vertices go with which object. So I create a variable called UD, and I save the vertices in a branch of UD as ud.vert. I want to rotate this local coordinate system about the x-axis. So I start off with the ijk vectors 1, 0, 0, 0, 1, 0, 0, 0, 1. And then I use another old function called vecRotate, which rotates vectors about a specific axis. I'll rotate the ijk vectors every 10 degrees about the x-axis. Each time I rotate, I'll save the ijk vectors as a 3x3 matrix and stack them as an element in a cell array. This cell array stores the orientation of the ijk vectors for each frame of this movement. Now I'll store that cell array in the user data as another branch called ud.ort. So now we have the vertices in the local system and the orientation of that system for every frame of movement. With these two pieces of data, we can now rotate the bar by the following algorithm. 1. Get a single frame of orientation from that cell array. 2. Get the vertices from ud.vert. 3. Calculate the new vertices using C-transform and transform the vertices from the local system to 1, 0, 0, 0, 1, 0, 0, 0, 1, the global system. And number 4, set the patch to the new vertices. And of course, number 5, repeat those steps for every frame of your movement. And there you go. Finally, a movement. We rotate the ijk vectors and the cylinder comes along for the ride.